afternoon, everyone. So, in the last lecture, we have studied what are utility angles, and now we have to find out the trans- uh, transformations, okay, from space of axis to body set of axis. What are space set of axis? These are nothing but your x, y, z, the original 3D space. And what are body set of axis? The body set of axis are these are x, y, z, space set of axis. Now we have to find out the transformation from x, y, z to x dash, y dash, and z dash. Okay, for that first transformation we have written, let me repeat as we were having some confusions, right? So we will have a transformation of xyz to x1, y1, z1. In this case, we will have a rotation through an angle phi, and as well as here we are going to fix out z-axis. Okay, that means your z is nothing but your z1. Fixing x, you have to have a transformation. Now let me show you the sketch. Suppose this is any rigid body. So here z is equal to z1, we are going to fix out. Now here you can see this is what x-axis. Now transformation or after rotation through an angle phi, you can see it is on x1. So this is y-axis. After rotation through an angle, it will be y1, and this rotation through an angle phi. Okay. Now we have the transformation equations also. I hope you have done the one that I have told you in the last lecture. X1 is equals to, what is the value of x1 now? It is in terms of x, y, and z. What are the coefficients of x, y, z? These are nothing but direction cosine. Let me check what is an angle between x and x1. It is phi. So cos phi will be the direction cosine. Angle between x1 and y. This is x1 and this is y. Angle between x and y1 is 90 degree, but it is in between x1 and y1. So we can write this as a cos of 90 minus phi. Next, we have to check the angle between z and x1, but we know that z is equal to z1. So angle between x1 and z1, it will be 90 degree. So cos 90. Similarly, let me write down the what is y1. Okay. Y1, we have to find out with the help of given x, y, z coordinate. What is the coefficient of x now? If I want to find out an angle between x and y1, this is what x and this is 1, right? We know that what is the angle between x and y? It is 90. As we know that x, y, z is a 3D space, x1, y1, z1 is also a 3D space after rotation through an angle phi. So now we have to put an angle between x and y1. X and angle between x and y is 90 plus this we have to add because it is away from 90. 90 is away, right? So we have to write this angle as cos of 90 plus. Okay. Next, we will find out an angle between y and y1. We can say here the angle between y and y1 is phi. Next, we have to find out the angle between y1 and z. But what is z? Z is nothing but your z1. If z is z1, what is the angle between y1 and z1? We know that they are 3D space. Angle is 90. Next, we have to find the coordinate of z with the help of x, y, and z. Okay, let us take what is an angle between z1 and x. But we know that what is z1? Z1 is z. So what is the angle between x and z? Angle between x and z is 90 degrees. So it will be again cos 90. Angle between y and z, which z is z1. So hence we can find out now angle between y and z is again 90 degree. Now let me check what is the angle between z and z1. If z is equal to z1, what will be the angle between z and z1? It will be nothing but 0. So cos 0 will be the direction cosines. Now this equation I can write as x1 is equal to cos phi x plus cos 90 minus 5. I hope the whatever the confusion will be removed. I will write directly the homework you have done it and in this statement. Okay, cos 90 plus phi 1 is equal to minus sin phi 90 prominent. So it is minus sin phi x plus cos phi y. That one here remaining between z1 equal to z because cos 90 is 0. So the coefficient of x and y is 0. The coefficient of z is 1. Now we have to write this equation in terms of x1 is equal to some matrix into x, right? So, which we can write it as x1 is equal to matrix D. X1 is equal to some matrix, say this is what the rotation matrix dx, which we can say that this is a transformation from x to x1, just like we have written for x dash to x. What is the transformation from x to x dash to x double dash? And then we have written the inverse also. At that time, we have written it is in the form of summation over a and out. And we have written the orthogonal, what is orthogonality condition. Right? Now, the x1 in this case is nothing but x1, y1, and z1. And here the matrix of rotation, which we can write with the help of coefficients and all. And here we have x, y, and z. Now let me write down what is this one. The matrix which we have obtained, we will write down first that matrix. Okay. Coefficient of x is cos phi, then x sin phi, next is 0 plus next here coefficient of x is minus sin phi, cos phi 0, and next here 0 0 1. So this is a matrix of transformation from x to x1. The first one we have obtained. Let me give the name for this equation. We can say it is equation 1. The first transformation we have obtained. Let us go for the second transformation. Second transformation, in that we are going to have rotation through an angle theta. First found the rotation through an angle phi. Now we have to obtain the rotation through an angle theta. In that case, we are going to fix the x1 axis. Firstly, we have fixed the z axis. Now we are going to fix the x1 axis because already we have performed one rotation. So x is now changed to x1. So now we are going to fix out x1. Fixing x1 means what? X1 is equal to x2. That means we are performing the second rotation. Okay. So that let me draw the image so that you can understand easily how to write down the transformation equations. Okay, here you can see first one was our y, then y1, and here is y2. Let me write down this is y1, y2. First is rotation through phi, next is a rotation through an angle theta. And as I told you that this is x, and we have to perform a rotation in such a way that x is equals to x2. Fixing x1 axis, we are going to perform the rotation. First, we see that here z is equal to z1. We have done a first rotation. Now this will be changed to z2, right? In that we can write this z2 according to an angle theta. Okay. If it has rotation through angle theta, here also we can write this is a rotation through an angle phi, initial rotation. But x1 is equals to x2. In the second thing, a second rotation, we are going to fix a x-axis. Okay. Let me write down the transformations from x1 to x2. That is x2 is equal to, we can write it as in terms of say x1 and y1 and z1. Now let me check what is the angle between x1 and x2. You can see here what is an angle between x1 and x2 is 0. So you can write as cos 0. Next, angle between x2 and y1. What is an angle between x2 and y1? You can check here. x2 is nothing but x1, right? x2 is nothing but x1. If you can see here, if x2 is x1, what will be the angle between x1 and y1? As it is 3D space, so we can write it as cos 90. Okay. Okay, again x2 is equal to x1. What is an angle between x1 and z1? Again it is 90 degree, cos 90. So direction cosine cos 90, which is 0. Now let me write down the second one, that is y2 is equal to. Now let me check what is the angle between x1 and y2. You can see here x1 is equal to x2. If x1 is equal to x2, what should be the angle between x2 and y2? It will be 90 plus. Next, we have to check an angle between y1 and y2. You can see here what is an angle between y1 and y2? It is theta. Okay, I can write it as cos theta. Next, we have to check an angle between z1 and y2. This is what z1 and here is y2. Now we can see here z1 is nothing but z. Okay, and here we can see here the angle between z1 and y1 is 90, and this is in between these two. So it should be, what is an angle between z1 and y2? It will be 90 minus that theta. So I can write this as a cos 90 minus theta. Next, let me write down the next one, that is third one, z2 is equal to, what is an angle between x1 and z2? Right. X1 is nothing but your x2, so what will be angle between x2 and z2 is 90 cos 90 plus. Next we have y1, angle between y1 and z2. What must be an angle between y1 and z2? You can see here angle between y2 and z2 is 90 degree. Plus this one we have to add. Okay, this y2 and z2. y2 और z2 के बाहर y1 है, right? So we have to write this as cos of 90 plus that and we have to add. Right, so we can make now the angle between these two is cos 90 plus theta. Next, we have to check an angle between z1 and z2. You can see the angle between z1 and z2 is theta, so it will be simply cos theta. Let me write down again, it's in the form of that matrix, right? Which we can write it as x2 is equal to some matrix. So in this case, we are going to name the matrix as a matrix C. This one is a transformation from x1 to x2. Right? Now for that, first we will write down what is x2 is equal to. Now for writing this, cos 0 is 1. So we can write these equations as x2 is equal to x1. Next y2 is equals to cos theta into y1 plus sin theta z1. Next y3 is equals to, z is equal to z2, which is equal to minus sin theta into y1 plus cos theta z1. Right. Now let me write down this in form of this matrix. That x2 is x2 y2 z2, which is equal to 1 0 0, and here is also 0 0. So you can write here cos theta sin theta minus sin theta cos theta, and here is x1 y1 and z1. Okay, so this is what matrix C, which is a transformation from x1 to x2. Now next we have to see the transformation through an angle, rotation through an angle psi. Okay, third one. Now let us have a rotation through an angle psi. Now we are not going to change. Initially we have fixed out z is equal to z1. Next, we have fixed out x1 is equal to x2. You might be thinking that now we are going to fix out the axis, but not as it is in the notes. I also don't know what is an exact reason behind that. We can also do that. I have tried it. You can also try it, but whatever things are there in the notes and in your recommended book, that I will do. Here we are going to fix out the z2 axis. Okay. First, z is transformed to z1 after in this rotation. In second rotation, z1 is now z1 is changed to z2. That means it is having some rotation through an angle theta. Second मध्ये z2 पर्यंत आले होते ना आपण. Now we are going to fix the z2 axis. That means z2 should be equal to z3. We are not having any rotation through an angle phi, without rotation through an angle psi, but we are not going to fix out the y-axis in this case. Okay. Now let me do a sketch for that once again. Here you can see the first one we will draw is y is changed to y1, then y1 is changed to y2, now y2 is changed to y3. So this is what an angle psi, here is theta and here is phi, and initially we have the x coordinate x-axis is changed to x1, but in the second one x1 is equals to x2, now x2 is changed to x3. Initially we have an angle phi, next we have an new angle psi, because for the second one we have rotation through an angle theta, but x1 is equal to x2. Now you can see here, next z is equal to z1 we have fixed out, but next we have performed the rotation through an angle theta. So we can write it as this is z2 through an angle theta. Now z2 we are going to fix out. Z2 is equal to z3. Okay. So if z2 is equals to z3, we have to perform a rotation through an angle phi. Okay. Now let us write down the transformation equation. X3 y3 in z3 we have to write x3 is equals to y3 is equal to in z3. So x3 we have to write down now in terms of x2 plus y2 plus z2. Here also y3 we have to write down in terms of say x2, y2 and z2. Z3 is equals to in terms of x2 plus y2 plus z2. Okay, now we have to find out what is an angle between x2 and x3. For that, we have to find out an angle between x2 and x3 psi. We can write it as directly cos psi plus next angle between x3 and y2. Angle between x3 and y2. What is angle between x3 and y3? It is 90 minus this one. So it is cos 90 minus psi. Next, we can check now angle between x3 and z2. Angle between x3 and but z2 is equal to z3 in this case. So the angle is cos 90. Thus next we have to check an angle between x2 and y3. This is x2 and here is y3, right? Now we can see here what is the angle between x2 and y2 is 90 plus this angle here. So it is cos 90 plus psi. Next, we have to take an angle between y2 and y3. You can see it is cos psi plus. What is an angle between y3 and z2? Here you can see angle between y3 and z2. Z2 is nothing but z3. So the angle I can write is cos 90. Okay. Now let's go for next is angle between z3 and x2. Z3 is nothing but z2. So angle between z2 and x2 is 90 cos 90 plus angle between z and y2. Z3 is z2, so hence angle between z2 and y2 is again 90. What is angle between z2 and z3? It is fixed out, both are same, so hence angle is 0. Okay, so we have this. Now let me write down the direct transformation from x2 to x3. So the transformation equation, now let me write down this as transformation from x2 to x3, and we will name this as some matrix A, B. This is a third equation. First equation we have obtained is a transformation x is equal to some matrix X. This is the first equation we have obtained. Next equation we have obtained it as x2 is equal to some matrix C into x1. This is what our equation 2. Okay. So after all these equations, before that, let me write down this one. x3 is equal to bx2. For that, x3 is equal to, we'll write the matrix of rotation B, in which we can write this as cos psi, sin psi, 0, 0, 1, minus sin psi, cos psi, 0, 0. Right? You can see here, this cos psi, cos of minus psi, sin psi, plus cos p 0, cos p psi, sin psi, next cos 90 here equation is equal to cos 0, so cos 90, and the last one is 0. So z2 is equal to z3 is the equation we have obtained. Okay. Now you can see here, let me go through the first one. The first transformation equation in which we have obtained matrix. You can see here, you have a transformation, or if you are having a rotation through an angle, if you have a rotation through an angle phi, and if you are going to fix out a z-axis, if you fixed out a z-axis, you can see the third column and third row is fixed out 0, 0, 1, 0, 0, 1, and the corresponding changes cos psi, sin cos phi, sin psi, minus sin phi, cos phi. Okay. Similarly, you can see for if you're having a x-axis is fixed. If you fixed out the x-axis and rotation is through angle theta, so if x-axis is going to fix out, the first row and first column is fixed 1, 0, 0, 1, 0, 0, and the corresponding changes. Whatever we have here is cos phi, sin phi, sin minus sin phi, cos phi. But instead of having that, here we can have cos theta, sin theta minus sin theta, cos theta. Now the last one already we have fixed out is the z-axis. So the third row and third column is 0, 0, 1, 1, 0, 0, 1. Right? So you can see the similarity. Now you can have the, if suppose you are going to fix out the y-axis, what will be the change? Let me write down that change. Say second row and third, second row and second column is 0, 1, 0, 0, 1, 0, and the corresponding changes cos, sine, whatever may be the angle, minus sine, cos. Okay. So you can now write down all the matrices whatever we have obtained after notation and fixing x or y on the axis, and you can check the corresponding changes. And this question is very important for the state exam also. Many times question is there, what will be the rotation matrix if rotation is through an angle, rotation is through an angle theta, and x-axis is fixed out. So if x is fixed out, theta is also given to you, you can write the matrix. Okay, now whatever equations we have written just now, these three equations we have combined. How to combine these three equations? For that, here we have x to b, x2, right? I will write down the equation to here. B as it is. What is x2? It is nothing but c into x1. Okay. Plus bc as it is. What is x1? X1 is d into x. Right. So in general, now we have found the transformation from x to x3. Just like the thing we have done initially, we have a transformation from x to x dash, then x dash to x double dash. Then we have written it is as transformation from x to x double dash. In the very similar way, here we have worked out actually that how to transform this. This x3 is nothing but your x dash. That is initially what was our aim? We have to find out a transformation from xyz to x dash y dash z dash. For that, we have gone for a step-by-step procedure. First one, transformation x1, x2, and x3. This x3 is nothing but your x dash. Hence, now we can write x dash is equal to b c d into x. Right? Now, if you remember, the question was you have to obtain the rotation matrix. That means we have to multiply the matrices b into c into d. You have to multiply these matrices, and that we can write it as say some matrix A. So if it is a matrix A, then we can write this as x dash is equals to A into x. That is a transformation from x to x dash. Okay, now let me write down A is equal to B into C into D. All three matrices we have to write, and then you have to multiply all these matrices, and the resultant you have to write this. Okay. In the live lecture, I will ask you what is a matrix A, which is a multiplication of B, C, D. That I will understand how many of you have seen actually the lecture. Okay, actually this is a recorded lecture. So thank you everyone. You have to answer this question.